Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on November 6, 2025, just yesterday. This paper unveils GUI-360, a unified desktop agent dataset and benchmark with over 1.2 million executed action steps, and shows that off-the-shelf vision language models struggle with grounding and action prediction, while supervised fine-tuning and reinforcement learning deliver sizable gains but still miss human-level reliability. The paper is titled GUI-360, a comprehensive dataset and benchmark for computer-using agents. And as we'll see later, the unified tasks and hybrid GUI and API action space carry significant implications for training robust desktop agents. Alright, Figure 1 shows the three core tasks that the benchmark evaluates, which map the screen, locate targets, and choose actions. GUI grounding means selecting the exact on-screen element for a step. Screen parsing lists all interactable items with their properties, like names and boxes. Action prediction decides the next operation, such as click or type, given the goal and current state. Together, these tasks capture what a desktop agent must master. Well, Table 1 contrasts existing GUI datasets against the benchmark's needs, and sets the stage for why coverage matters. It highlights that GUI-360 is the only resource covering grounding, parsing, and action prediction with automated collection. It also includes accessibility information, which means machine-readable labels for interface elements that help models reason about what to click. The bottom row indicates hybrid GUI and API actions plus failure cases and reasoning traces, so the benchmark supports both perception-driven and tool-assisted agents. Okay, Figure 2 shows the automated pipeline that turns real user intents into validated desktop interaction data. The left block gathers prototypical queries and builds environment templates, which ensures tasks mirror everyday office work. The center block runs TrajAgent to execute steps, log screenshots, and capture accessibility metadata, meaning machine-readable labels for interface elements. The right block performs trajectory validation and data structuring, so only clean, well-formed traces enter the benchmark. Well, Figure 3 shows how TrajAgent turns a concrete task into logged desktop trajectories. The perception block captures full-resolution screenshots and accessibility information, which means machine-readable names and boxes for on-screen controls. The central agents plan and execute steps, while the recorder logs pre- and post-states, so traces stay time-aligned. The action executor uses MCP servers, a plugin-style bridge to app tools, and API calls, and the outputs accumulate as collected trajectories. So, Table 6 reports dataset scale and composition for training and benchmark splits. The top block summarizes the training split with 14,000 trajectories. It shows about 8 steps per trajectory, which signals medium-length tasks. The corpus includes around 18 million annotated elements, so models get dense supervision. The bottom block lists the benchmark split with 3,000 trajectories. GUI action rate versus API action rate highlights the hybrid setup, meaning some steps click while others call tools. So Table 7 summarizes grounding accuracy across Word, Excel, and PowerPoint, showing how task-specific training changes outcomes. General-purpose models scored under 12% overall, which indicates they often miss the exact on-screen target. Domain-focused pre-training lifted accuracy to about 54%, so specialized grounding helps substantially. Supervised fine-tuning on the dataset reached about 82% across the applications, which marks the biggest jump. Excel remained tougher than Word and PowerPoint, suggesting dense spreadsheets complicate precise localization. Wrapping up, 2 takeaways stand out. The unified dataset and benchmark finally cover grounding, parsing, and action prediction at desktop scale, and general vision language models still falter, while task-specific training and accessibility metadata deliver big gains. The broader implication is clear. Robust desktop agents will need hybrid GUI and API skills plus targeted supervision. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.